Hello everyone, and welcome to our video on evaluating inverse trig functions. So we broke down in a previous video what their domains and ranges are. So we have to be very careful of that when we answer these questions. So typically, again, it's in radians, but sometimes we could answer it in degrees. So some of these we'll kind of mix up. There are other notations. So the sine inverse of x is also called arcsine of x. So actually I don't have much room. Let me do tangent. So, and similar with cosine and tangent, but that's tangent inverse of x is how we would say it. This is arctangent of x. Okay, so they are the same thing. What they are doing is finding an angle. All of them find angles. So notice that our ranges on these, radians or degrees, those are angles. So that's always the main thing to think about with inverse trig. Inverse trig finds angles. Okay, so inverse, let's put that right here. Inverse trig finds angles. Okay, and without a calculator, it should be kind of our main ones on the unit circle. Okay, and so the reason they use arcsine, arccosine, and arctangent of those x's is because what they're often stating is you are measuring, so remember the pi measures on our circle are some angle measurement involving pi. So there's a picture of an arc. So in the blue, that's our arc, and then it gives you some terminal point. Okay, anyway, one other thing that can be used before we evaluate these is we can use our golden rule for inverse trig. So they all follow this and they can be used to check or to use other methods involving inverse trig functions. Let's go ahead and box that. What it's saying is inverse trig, so sine inverse of x gives us an angle. If we rewrite it to put it in normal trig, so not an inverse, then sine of the angle should equal that original x. Okay, so it's just going back and forth. It's kind of a way to check. Or to use SOHCAHTOA if we need to use SOHCAHTOA. That's with right triangles that we either have seen or will see. Okay, so it depends on, I guess, the order. All right, but let's evaluate these. Okay, so to evaluate these trig functions, I just use the unit circle. So most of the time they're making you do it without a calculator, without another reference. Okay, so these ones are without a calculator. We're going to find the exact value of each trig expression. All right, so what we've got, inverse trig expression. So I'm going to draw my unit circle here. And what this is saying, okay, so cosine inverse of radical 3 over 2 should equal some angle. So this is going in reverse of what we usually do. Right here, so cosine's still connected to x coordinates. So they're saying this is an x coordinate on our unit circle. Well, where I have an x coordinate of positive radical 3 over 2 is right here. So there's positive radical 3 over 2 and 1/2, and it has the angle, well, again, going in reverse, that is the angle pi sixth. Okay, so that's the one that they want. So cosine inverse also, going back to our domain and range of cosine inverse, it has to be between 0 and pi. Okay, so cosine inverse somewhere where it's highlighted between 0 and pi. That's the only positive x coordinate between 0 and pi. Okay, so over here would be a negative x coordinate, so we don't want that on this problem. Okay, so we don't care about that on this one. Okay, so it is just pi sixth. Done. And if we needed it in degrees, we could convert it. Okay, so I'm gonna not box that. If they do want degrees, I mean that the 30 degrees is the answer, but typically they do want radians. All right, so sine inverse. Sine inverse of radical 2 over 2. Well, sine inverse of radical 2 over 2. Again, let me maybe mark this first in blue where our answer can be. So sine inverse must be between those two angles, in between positive pi halves, or between negative pi halves and positive pi halves. So nowhere else. Okay, so quadrant 4 and quadrant 1, but quadrant 4 would be negative angles. Okay, so I'm just kind of converting the information for our range into the unit circle information. And then now what we're looking at, let's mark this in red this time. So sine is still connected to y coordinates. So they're saying this time this is a y coordinate and we're working backwards to get the angle. Okay, so sine inverse of positive radical 2 over 2. Well, that is in quadrant 1. Okay, so this is where if we really know our unit circle well, we can remember these and then work backwards. And then we would say, well, where I have that terminal point, again, the y is what's important. I know that that angle is pi quarters. Okay, so this sine inverse of radical 2 over 2, the answer is pi over 4. Okay, or 45 degrees if we're doing degrees. Okay, so that's that answer. Okay, so let's keep going. Let's do a handful of these on this problem. So I've got 6 others. Again, you could pause and try them out on your own. Okay, so here we've got cosine inverse. And notice I'm drawing my little unit circle just like I would for regular trig. Let's mark it though. We know it has to be between, so cosine inverse every time is in between 0 and pi. This time again, that's an x coordinates. Cosine is always connected to x. Cosine inverse of negative radical 3 over 2. So I'm thinking, well, where do I have negative x coordinates? Well, in quadrant 2 I do. Okay, so negative radical 3/2 and positive 1/2, but the main thing really is the x coordinate. And then I'm thinking, well, working backwards, how do I find that? I'm still trying to draw these accurately, so it's long on the x. So I know that that is with 6 in the denominator if we're doing our radians. And if I'm in quadrant 2, it's around 5 pi over 6. Okay, so cosine inverse of negative radical 3 over 2 is 5 pi over 6. Again, that's the angle. And here's where I didn't use the other rule yet. You can kind of check it. You could plug it in and say, well, cosine of 5 pi 6, yeah, that is the negative radical 3 over 2. So that's using this rule right here that we boxed. I didn't use it yet, and you could do it with these others as well. Okay, so but the check might backfire if we forget about the specific ranges that these answers are in though. So it has to be in those specific ranges for an accurate answer. Okay, so you can't, so if you said, oh, shouldn't it just be, isn't 7 pi 6 also an answer? Because that also has a negative radical 3 over 2 as an x coordinate. Well, no, because it's not in the range that we highlighted in blue. Okay, so the blue kind of went away. Cosine inverse answers have to be in that range. So that's why that one's gone. It's not in that correct range. Okay, so that's not an answer. Okay, and again, if they did say, well, I want degrees, I mean, we could convert it just real quick. It would have been 150 degrees. All right, let's do tangent. All right, so we haven't seen tangent yet. What could be helpful with tangent? I'm going to draw our quadrant 1, and this could have been helpful for the others as well. Okay, so in the black ink, I'm going to put our angle. So 0, pi 6th, pi quarters, pi thirds, and pi halves. And then their terminal point, I'm going to do in the blue, 1, 0, radical 3 over 2 and 1/2, radical 2 over 2 and radical 2 over 2, 1/2 and radical 3 over 2, and then 0 and 1. And then let's write in red the tangents. So tangent would be to divide the y coordinate by the x coordinate. All right, I'm going to do that without showing the actual work. So the 0 divided by 1 would be 0. 1/2 divided by radical 3 over 2 would eventually become radical 3 over 3. These two numbers are the same. When they divide, it's 1. When our y coordinate divides x here, we get radical 3. And then 1 divided by 0, that's undefined. Okay, so those are the tangents of those angles. Okay, so just to mark 1, so we're saying that tangent of pi 6 is radical 3 over 3. Just the quick way to do it. Okay, and the reason that we got that is, well, that makes doing tangent inverse a little easier. So using our, again, I would sketch out the circle for these problems, and then again, if we know our unit circle well, they all become much easier. So we've been stressing it since day one, that unit circle is super important. All right, so square root of 3 over 3 on our tangent inverse. Again, we do have to remember that tangent inverse is between those two, just like sine inverse. However, it's just a little harder to figure out. Well, again, that quadrant 1 information is where it's useful. Right here, I kind of already wrote it. There's the radical 3 over 3. Okay, so it looks like we just need to go a little bit up. There it was. So that's where we would have, oops, I wrote 3 down. I was thinking radical 3 over 3 and wrote a 3. That should be pi sixth. Okay, so again, the angle is what we're trying to find. Okay, so the coterminal point or the terminal point was where we had radical 3 over 2 and 1/2, but the tangent of it is radical 3 over 3. And then going backwards is the angle pi sixth. One thing that might help remember what's going on, or that might help with finding angles involving tangent inverse, is that you have a 3 here and another 3 here. 3 plus 3 is 6. Okay, so if you see the radical 3 over 3, it's something that has a 6 in the denominator for tangent. Okay, so that might help with that. And then also, just to highlight, I'm going to underline, the one with radical 3 and pi over 3, there's a single 3, single 3. Okay, so that might help with evaluating tangent inverse. All right, now let's do some negatives. All right, so arc sine of negative 1/2. So still I'm going to sketch out a circle. And still in blue, highlight where our answer would be. So sine inverse. So arc sine and sine inverse, remember those are the same. So if you wanted to rewrite this like that, that's fine too. Okay, but our answer must be between negative pi halves and positive pi halves. And this sine, so sine and cosine are a little easier to work with. This is a y coordinate. Again, this is saying you have a y coordinate. In this blue region, I know the y-coordinate would be negative in quadrant 4, just a little bit below the y-axis right here. Okay, so let's now start marking it in red. So we went that way downward. And I'm thinking, well, I had to go clockwise to get there because I'm in this blue region only. I can't go all the way around. So I don't want to go all the way around like that because that's not part of the blue region here in our answer. So I don't want to do that. Instead, I would just say, well, going clockwise would be a negative pi sixth. Okay, because we know our coterminal, or not just our terminal point is the positive radical 3/2 and negative 1/2 right there. Again, I was looking for a y-coordinate just slightly below the y-axis, or x-axis, slightly below the x-axis. I know involves a 6 in the denominator. This final answer is negative pi sixth. Again, and that's the only answer. Okay, so if you wrote, oh, is an 11 pi 6 equivalent because that's in quadrant 4 also? No. Okay, so again, it has to be in that specific range. That's no good. Okay, so just a single negative pi 6th answer. Or if we're doing degrees, negative 30 degrees. Okay, so, and I didn't do it with the tangent inverse problem. That would have been 30 degrees also. All right, so if we're doing arctan, back to arctan. One thing to notice about arcsine, let's do one other color here. I'm going to do it in purple. If I were to have used the positive, so there's positive pi sixth, and get that terminal point, that would have been positive radical 3/2 and positive 1/2. Notice that when I have a positive 1/2, I have a positive pi sixth. When I have a negative 1/2, I have a negative pi sixth. So it's just saying, well, if you have a positive, do a positive angle with sine inverse. If you have a negative, do a negative angle with sine inverse. It works the same way with arctan. Okay, so let's add that note right here. So if we have sine inverse of a negative or tangent inverse of a negative, our answer will be a negative angle. Okay, so that means this arctan of negative radical 3 over 3 will also be a negative answer. Okay, however, again, I'm going to draw my little circle real quick and highlight Here's our negative pi halves to positive pi halves. That's where our answer must be for arctan. All right, and then, well, I can kind of recycle the work. For number 4, I see, again, I have 3 and 3 involved. Let me do it in red. So I have a 3 right here and a 3 right here. So I know it should be something with pi sixth. So it's got to be one of those two only. Okay, so that, but the quadrant 1 would have been positive pi sixth. That's what we did in the previous problem up above. So that must mean I'm looking for negative pi sixth. There we go. That's it. Okay, so it's negative pi sixth for our answer. Okay, so again, tangent inverse and sine inverse are kind of nice when they put in a negative number. It is just finding really, you could treat it like a positive and then just put a negative for a final answer. Okay, so or, I guess we could put or negative 30 degrees if they want degrees. Okay, so that's that one. Let's do, I'm going to change this arc sign right in the middle of this. Let's change it to cosine. So we have a negative cosine involved with inverse trig. Okay, so one other, or two others. Okay, so we have arc cosine of negative 1. Again, one more time, we could say, well, I know our answer for inverse cosine must be between 0 and pi. So we'll mark it right now. And then we see, oh, this is, again, some x-coordinate. X-coordinate of negative 1 is over here. Okay, so that's where the negative 1 x-coordinate is. And we know this angle is, well, pi. That's it. Okay, so arc cosine of negative 1 is pi. Again, or if we do a quick conversion, 180 degrees. All right, that's that. Now, cosine inverse of pi. Here they're trying to trick you. Okay, so again, this is an x-coordinate. They're saying this is some x-coordinate here. And our pi has an x-coordinate. Remember, this is 1, 0. This is negative 1, 0. Let me mark it in blue, just like I did the last problem. So if it's there, it would be somewhere in this region here. While pi, remember, pi is about 3.14. Pi is bigger than 1. Okay, so that means it's somewhere over here, I guess, or somewhere. It's not on the unit circle. Okay, so that x-coordinate is not on the unit circle. So sometimes you can get undefined in these problems. Okay, so this is undefined. Okay, and it goes back, let's scroll one more time. It goes back to this initial video where we started with inverse trig. Here's the domain. Pi's not in there. Okay, so it's got to be between negative 1 and positive 1. If we plug it into a calculator, say we say, oh, I don't know, because these next ones do require a calculator. We'll do that in a different video. But if we say, oh, let me double check it, it's going to give an error in the calculator because, again, it's not in the domain. So it has, so with sine inverse and cosine inverse, what we plug into there must be between negative 1 and 1. Now, all of these happen to be on our quoted unit circle, so we could do it without them. These ones, notice 1/4. 1/4 is between negative 1 and positive 1, but it's just not on the quoted unit circle. However, we should be able to find it still. And that what we'll show in the next video. So that's it. Okay, so these ones really just unit circle in reverse. Try to get that practice in the best you can. Lots of unit circle. Again, the whole course is highly dependent on it. Okay, good luck with it. If you do have questions, please let me know. And thanks for watching.